Hello students, Ms. Wolfram here. Let's talk about difference quotients in section 2.1. What is a difference quotient? The expression we have here, f of x plus h minus f of x over h for h not equals 0, is called the difference quotient, and it is a very important idea in calculus, which is why we're emphasizing it here. We can think of it as finding the slope of the line connecting 2 points of the function. And so we are talking about the difference in y values over the difference in x values. Here's the definition in big letters. What we're going to want to be able to do is to evaluate this difference quotient for different formulas of f of x. So I'm going to just give 6 different examples that have different characteristics and show you what to do. I'm going to start with 2 of them. First one is f of x is a very simple linear function, 7 times x. And the second one is only a slightly more complicated linear function, f of x is equal to 6x plus 1. We want to begin by evaluating f of x plus h. We do this by taking the function rule, and everywhere we see an x, make it into x plus h. So here's an x, and here's an x, and those will become x plus h. Only the x's are changed. So we started out with f of x equals 7x. f of x plus h is going to be 7 times. We change x into x plus h. And then we'll simplify that with a distributive property. Second one, f of x equals 6x plus 1. The x becomes x plus h. So we have 6 of x plus h plus 1, and again distributing 6x plus 6h plus 1. That's f of x plus h. Now looking back at the definition of the difference quotient, we'll complete the numerator by subtracting f of x. f of x is the original function. We'll use the original function formula. So here was our first one. F of x was 7x. We calculated f of x plus h, and now we're going to subtract f of x off of that. So here's f of x plus h. We subtract 7x. Notice we have a plus 7x and a minus 7x, so that cancels, and we're left with 7h for the numerator. Down here, f of x plus h turned out to be 6x plus 6h plus 1. We'll subtract 6x plus 1. Notice the parentheses, so we subtract the whole thing. So 6x gets added in and subtracted off. So does 1, leaving us with just 6h. Once we have that numerator, we'll put in the denominator h and reduce if possible, very carefully. Here we had 7h when the dust cleared, and when we divide it by h, we will have 7h over h, which does reduce to 7. Here we had 6h in the numerator. Divide by h, we get 6. Let's look at a few more problems. Those were very simple. This one is not so simple since it is a rational expression, a fraction. What is f of x plus h going to be? How do we get it? We replace x with x plus h. Only x's get replaced. So our denominator for this part will be 2 quantity x plus h. In this case, it's not useful to multiply out with a distributive property because of the way subtraction of fractions works. The numerator is going to be f of x plus h minus f of x. That's this expression minus this expression. They do not have a common denominator. We have to get a common denominator. The lowest common denominator is 2 times x plus h times x. So, changing those two fractions to have the common denominator, we'll have x over the common denominator minus quantity x plus h over the common denominator. And here we can, in the numerator, use distribution. We'll have x minus h all over this denominator. Numerator turns out to be h over 2 times x plus h. That's our numerator. Now, our difference quotient is that divided by h. Let's divide by h by multiplying times the reciprocal. And that h then will cancel with this h, leaving this expression. Be careful with fractions. We can't cancel from terms. For example, none of the x's anywhere here are going to cancel because they're not factors of both the numerator and the denominator. Be very careful about that. This one, not so difficult. F of x plus h will replace x with x plus h. Be careful about squaring. We've got to use FOIL. Distribute. Subtract the original expression. And then notice that h is a factor of both terms here. So we'll factor that out. Here's the numerator. We'll put it over h, and those h's will cancel. So for f of x equals 2x squared, the difference quotient is 4x plus 2h. Sounds strange, but that's where it comes from. F of x equals x squared minus 5x plus h. Here is an x, and here's another one. So both of those get replaced by x plus h for our f of x plus h. Be sure to use FOIL on this one. Be sure to distribute our minus sign and our 5 to get the numerator that looks like this. And look at what pieces cancel. X squared minus x squared, and minus 5x plus 5x, and plus 8 minus 8. So there's quite a bit of simplification here, leaving us with 2xh plus h squared minus 5h, and all of those have an h in them, so we can factor the h out, and that gives us, when we have our denominator included, something to cancel. And our answer is as follows. One more. F of x equals 7, the constant function. What is f of x plus h? Too many students want to say 7 plus h. Is there an x here? No. So there's nothing to replace with x plus h. F of x is 7. F of x plus h is still 7. So the numerator is going to be 7 minus 7. It's going to be 0. When we take 0 and divide it by h, we get 0. I really love to put constant functions on tests. That's how I find out who was paying attention when I said, since there aren't any x's, there isn't anything to add an H to. I look for that attention. Okay, you will find in your content a worksheet. Part 1 of the worksheet gives 10 functions, and all you are to do on Part 1 is to do the first step of the difference quotient process, write and simplify the f of x plus h expression. Part 2 looks strangely familiar because it has the same 10 functions. What I'm asking you to do there is to finish the computation. You've already done step 1. Be sure you show all your work. Also, you need to check your answers. I've given you the answers. Check your answers as you go along. How am I going to know you do that? I read minds. No, I don't. You need to put check marks by your answers when you've checked them. When you're done with your worksheet, submit it through the Dropbox. And this is what I will do. When you finish and submit the worksheet, you are excused from the section 2.1 homework and quiz in my math lab, because that's all about the difference quotients and the worksheet does a better job. So when you do the worksheet, submit it. I will give you the same score on your section 2.1 homework and quiz that you received on the worksheet. You don't have to do any more on that. Here's a bonus point opportunity. For your bonus points, I'd like you to think about what I was just talking about, the constant function. Use this subject line, DQ bonus points, and in the body of your email, explain why f of x plus h does have an h in it if f of x is a function like f of x equals 7x. But if f of x is a function like this, f of x equals 7, there's no h in f of x plus h. Explain that to me, and I'll give you bonus points. That needs to be within 2 weeks of the beginning of whatever week it is that we are studying difference quotients. All right, as always, I'd be glad to hear from you. I'd be glad to have your questions, and I'll see you next time.